Okay, it's time to get serious.
Hello, Logic people. Hopefully you're healthy and safe. Welcome to my garage, where we'll be seeing a number of video feeds on our textbook, material from our textbook. Today, let's look at Chapter 13, Truth Tables, and we're only going to look at one section at a time. These videos will be kept fairly short. Remember our 5 truth functional operators: negation, symbolized by a tilde; conjunction, symbolized by the ampersand; disjunction, symbolized by a wedge; conditional, symbolized by an arrow; biconditional, the double arrow, because it involves 2 conditional statements. All right, what we're going to do is really see how they operate truth functionally. Remember, we talked about how they're all truth functional operators and what that means. So what we're going to do is truth table each of these operators one by one. So if we take the operation of negation, let's say you negate a formula. And let's call that formula, we're just going to express it as a simple statement here. Negation of this simple statement P, right? Let's truth table that formula right here. What we're going to do in a truth table, we always put the formula to be tested on the upper right. Okay? So the formula to be tested, that'll be in the upper right of our truth table. And we create a truth table like this. All right? Now in the upper left, you put all the statement letters involved in the formula to be tested. We only have one statement letter involved, and that's P, so put that there. Okay? Now, in our logical system, each statement, each formula has only 2 truth values. It's either true or it's false. Remember, that's the way we define statements. So P, whatever it is, right, is either true or false. Okay? This is called a column right here. This is a column. And each of these right here, going horizontally, are rows. All right? Rows represent different truth value combinations, truth situations, you could say, or what I like to say is each row represents a possible world. And we'll use that language more as we go. All right. In a situation where P is true, what is not P? Well, it would be false. There's only 2 values on our system, so if it's not true, then it must be false. Okay? So in other words, you can put it this way. In a possible world where P is true, not P is false. In a world where P is false, the negation of P, or not P, is, you can guess, true. Okay? Now, we did fill in the values under P right here. In a complete truth table, you would have truth values under each column. Now let's look at this truth table. There are actually 3 columns. This column under P, the column under this operator right there, the negation sign, and then the column under P right here. We don't really need to repeat the values under this P here because they're just right here. They're very visible, they're very obvious what they are. But if we're going to give a complete truth table, we would say T and F. Okay, in effect what we're doing is we're taking the values under P here, we are copying them and pasting them over here. Every time you see P in whatever formula you get, you're going to have the same column repeated over and over and over. We've just truth tabled the operation of negation. Okay. Let's look at second operation, conjunction. Now, conjunction can always be represented as P and Q. Or as remember we've done before, we've expressed it as circle and square. It's the same idea. But when we truth table, we're not going to be using geometrical figures. I use geometrical figures in our proof system, but for truth tables, I'm just going to use letters. It's easier to handle. I'm going to erase this here. Okay, so we are going to truth table the operation of conjunction represented by P and Q, and we're going to put it in the upper right of our truth table, like this. There we go. Okay, look at this formula right here. How many statement letters are involved? Two different ones, P and Q. Put them up in the order that you see them, P and Q. Okay? Hear the rain outside? It's kind of nice, I guess. All right. P and Q. Look at this. When you have two statement letters here, and you look at their truth values, there are how many possible combinations of truth values with two letters here? When you had one letter, there were two possible combinations. With two letters, you could probably guess, there's four possible combinations. So this is the way we're going to list those combinations. In the left-hand column, we're going to alternate TF and TF. Like that. Q, the second column over here, we are going to alternate in twos, TT, FF. So this is the pattern we're going to use for two statement letters. And notice that it covers all the possible combinations. P and Q are either both true, P is false, Q is true, P is true, or Q is false. And then finally, you have the final option here, P is false, Q is false. All right? So if you have two letters involved, you're going to get 4 rows. Not 3, not 5, not 6. You're going to get 4 rows. With one statement letter, you will get 2 rows, always. All right. We'll talk about 3 statement letters later. All right, let's look at our truth table here. Now, in the operation of conjunction, what that tells us is this, is that in a conjunction, for the whole conjunction to be true, both conjuncts have to be true. And there's no other scenario, no other possibility, no other situation where the whole conjunction will be true. Okay? They're only true. Conjunctions are only true when both conjuncts are true. What that means in a truth table situation is this, that only one row of these 4 will come out to be true. And it's the first one, where both conjuncts are true. Makes sense there? All the other ones will be false. Like that. Okay? In a conjunction, both conjuncts have to be true. So you can look at this and you could say, a conjunction is not easy to satisfy. Not easily. And here's the logical term here, satisfiable. Not easily satisfiable. Only 1 out of 4 rows turns out to have the truth, to have a truth as its value. Okay, let's look at, I need to spray this stuff. Okay. All right, let's truth table the remaining 3 truth functional operators. Let's begin with the disjunction. Remember, we defined it in an inclusive way, which meant disjunction is true when one of the disjuncts is true or both of them. Okay? You can have, the ketchup or the mustard, or both. Okay? So, under that definition, we get true values in the first 3 rows, because at least one of them, I mean, in all of them you have at least one disjunct that's true. Disjunction is only false when both disjuncts are false. So T, 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 F. You can see it's more easily satisfiable than the conjunction. All right, let's get to the conditional statement. Conditional statements are a little bit trickier. It's truth-tabled in kind of a counterintuitive way. There's a reason for it, which we'll get to in a short video I'll post later. Okay, conditional statement, we have, remember, an antecedent and a consequent. All right? It is true in all situations except when the antecedent is true and the consequent false. So that's the only time a conditional statement is false. That's a little odd. You might expect it also in the 4th row or maybe the 2nd row, but this is the way our system works, and I will defend that later. So you're going to get in the 1st, 2nd, and 4th rows here, T's, and then 3rd row, a false. Memorize that. Memorize that. Because it's hard to understand it sometimes, so just memorize it. All right, biconditional. Remember what a biconditional does. It points to a logical equivalence between 2 statements here. Between P and Q, they're logically equivalent, which means that they should have matching truth values. And when they have matching truth values, you get a true statement. Something is water if and only if it's H2O. Something is Darth Vader if and only if it's Anakin Skywalker. Okay? So you get a true value here when they're both true. Right? You get a true biconditional statement when both components here are false. The other 2 rows where you get mismatching truth values, we have a false read here. Okay? So we've truth tabled all of our operators, our 5 operators. Memorize them. You're going to be using them quite a bit when you create truth tables. Let's see. Notice that the truth values in the main column in each of these, at least these 4 here, when they have 4 rows here, notice that you have different values in the main column, which tells you that the logical operations being tabled here are different. They act differently. All right, that's it for now. See you next time.